upside down and inside out. About to take your education on a brand new route. Because I'm Mr. Morris and I'm here to say that it's time to teach math in a brand new way. Because if you think that your math ain't great, you're starting to hate, feel you can't relate. Well, if you know fool, be sure to stay tuned. There's a new way of learning flows into you, yeah.
Hello everyone, welcome to Math Made Simple. I'm your host Chris Morris. Let's go ahead and get into this. So today's topic is how to add fractions. Now last week we looked at a video on what a fraction is and how to identify what are called equivalent fractions. I felt like we made a lot of progress and built a lot of understanding with some young people when it came to that video. This video is taking it another step further. So now that we know how to write a fraction or to calculate one based on part over whole, now we're going to start talking about how to do some operations with our fractions, which is an important skill as your child moves, especially into the middle school grades up before high school. You're going to have to do this all the time, and so it's not going anywhere. Math builds on itself. So what I want to just point out first is something simple, and I said this in one of my sessions this week, and I'm going to say it again to you now. When it comes to adding fractions, you must have what's called common denominators. I'll say it again. You must have common denominators. So let me go ahead and give you a quick example, right? Let's say we had the fraction 3 over 8 plus, I'll say, 4 over 8, right? This is an example. Let's take a look at my board if you can see that, all right? This is an example of two fractions that have the same denominator, or the bottom part of the fraction. Okay, what you need to understand is that if the numbers at the bottom of the fraction are the same, what I'm really saying is that they're basically the same size piece, right? Think pizzas for a second. If I had two pizzas that were each cut up into 8 slices and it was the same size pizza, large pizza at Papa John's or Pizza Hut or something, right? Well, then I know all the slices are equal, so adding them together makes sense. I can actually understand about the amount of the pizza that I'm getting, right? So if you need a visual, let me give you a quick visual. Let's say we have a pizza. I'm going to cut up each pizza, and imagine they're the same size. I'm going to cut up each pizza into 8 slices. And imagine that these are equal slices, because I am not an artist. I don't claim to be, but that's what I'm going to try to do. Okay, so going back to here, you see the two fractions, yet you also see the pizzas, right? That's the example. A fraction is a part of a whole. So notice, even though it's not very accurate because I can't draw perfectly, but imagine that they're the same size pizzas, right? That means each one of these slices, right, that I cut it up into are the same size. It doesn't matter which pizza I'm looking at. I know that the pizzas are the slices, are the same size. When I add them together, I'll have an exact amount of pizza to be able to report to somebody. How much pizza do we have? Okay, they can get an idea of how much pizza that really is. So what I'm going to do is I'm going to shade in the slices so you get an idea of how many pieces out of 8 I'm talking about with each fraction. So if you have 3 out of 8, remember that's the same thing as 3 slices that I am going to give to somebody, right, out of an 8 slice pizza. So it would look like this, if you can see that, okay, it would look just like this. 3 slices are out of 8. That's about how much of the pizza I'm getting, right? If I have 4 slices of an 8 slice pizza, that's basically the same as half, but let's just go ahead and shade that in so you get an idea. 1, 2, 3, and 4. So if you see the visual, it helps people understand amount. When you talk fractions, you want to emphasize it's about the amount of something as much as you possibly can. It helps kids make that connection in their mind. So you can clearly see if I have 3 out of an 8 slice pizza, which is what 3 out of 8 really means. It means I have 3 slices out of an 8 slice pizza, and I add 4 slices out of an 8 slice pizza. I have to add up all the slices that are shaded to figure out how much I have. So 3 plus another 4 would give me a total of, you guessed it, 7 slices. So I would say my answer is 7 out of the 8 slices pizzas that we're talking about. We have 7 1/8 slice pizzas together, right? Sorry about the glare there, but hopefully I can get the angle right? So that's kind of the understanding. For that reason, when you add two fractions together, you got to keep the denominators. You can't have different denominators, because if the denominators are different, let's say this was 1 out of 2, so that means you'd have the same size pizza, but it was cut up into only 2 slices. You'd have like these tiny itty bitty 3 of these little pieces plus 1 huge, it really wouldn't give you an understanding as to how much we're dealing with here. And so you got to have common denominators. Does that make sense? Okay. Now what do we do, moving on, what do we do when they aren't the same denominator, right? Sometimes it's not going to be that pretty, right? They're not always going to be the exact same denominator, yet we're still supposed to add them together. Well, let's take a look at that, right? Let's say instead of it being 3 over 8 plus 4 over 8, we had 3 over 8 plus 1 over 2, okay? That's going to be my next thing, 3 over 8 plus 1 over 2. Sorry about the glare. I might see if I can move the lighting, and maybe that'll be a little better for you, okay? Plus 1 over 2. Well, remember, 1 over 2 doesn't mean the pizza is any different in size. It does mean it's cut up into less pieces, right? So what I'm going to do is I'm going to try to draw the same size overall pizza, but I'm going to cut it into just 2 slices. So that's what that means. If the denominator is 2, then I only have 1, 2 total slices. But remember, it says 1 out of 2. So that means one of the slices we're eating or we're shading, but there are 2 total. So I'm going to shade in, watch this, I'm going to shade in one out of the 2 of this other pizza, right? It's a really big piece of pizza. I'd love to get that much pizza if it was pizza night, you know. But you can clearly see, just eyeballing this, that 3 out of 8 is not as much pizza as 1 out of 2. Even though 3 is a bigger number than 1, it's about out of the whole. You have to refer to it that way. But we can't just add them together as is. It gets a little confusing to say, okay, take 3 out of 8 slices plus 1 out of 2 slices. Tell me how much you have. I mean, it's kind of confusing for folks to describe an amount that would be. So what's easiest to do when that's the case, and notice the denominators are different, right? 8 and 2. So that means the pieces are different. That's a skinny slice, an 8 slice, and this is 1/2 slice. So that slice is way bigger, right? We want them all to be the same size pieces is what I'm getting at, right? So what's the easiest thing to do? Is it easier to change the one that's already cut up into 8 slices? Or is it simply easier to take the one that's in 2 slices and cut it up into more slices? If you guessed this one, you are correct. So I'm going to change this and just show you visually. I can change this 1 out of 2 to being cut up into 8 slices, and then that will change my fraction. Okay, so right now it's 2 slices. Now watch this. I'm going to cut it up into 8 slices. So I'm going to go 1, that's 4, do another cut. I used to work at a pizza place, so I'm pretty good at doing that, right? Not really. But look at that. This is the exact same amount of pizza. I didn't change the shading whatsoever. This is still really half of the pizza if you think about it, right? But now that I cut it up into 8 slices, that changes the fraction, right? So how many slices are shaded now? 1, 2, 3, 4 slices are shaded now, right? So this 1 out of 2 magically became 4 for the numerator instead of 1. And how many total slices are there? 1, 2, 3, 4, 5. There are 8 total slices after I cut it up. So bam, right here is something I want you to think about. We just discovered that 1 out of 2 as a fraction is really the same amount as 4 out of 8. Okay? I did not change the shading. When this was just cut up into 2 pieces, this much, half of the pizza basically was shaded in, right? But if I took that same pizza, cut it up into 8 slices, still half the pizza shaded in, but how many pieces is it? It's now 4 pieces out of the total of 8 pieces that were there. So my point in the circle there, that's the reason why you can do this. 1 out of 2 is really the same fraction as 4 out of 8. Now, why take the time to do that? Well, when I converted it to 4 out of 8, now the denominator 8 is the same as the other denominator from the first fraction. You see that? The denominators are the same, and I can add them. And so now we have a more specific amount that someone can understand. And so this is kind of the reason why we worked on that skill of going from one denominator to the other. And we talked about a multiplier. If you multiply 2 times a certain number, you could get 8 on the nose, right? And that number was 2 times, if you said 4, you're right. 2 times 4 equals 8. And so a little trick that people learn is to get a common denominator, you want to see, well, what do I have to multiply the smaller denominator by to equal what's on the other fraction's denominator, right? Well, in this case, it's 2 times 4 equals 8. And so the rule says if you multiply the denominator by a number, you have to multiply the numerator by the same number. And notice you'll end up getting what we just discovered cutting it up, right? 2 times 4 is 8. 1 times 4 is 4. 4 out of 8. That's what we figured out when we just cut it up into the same amount of pieces, right? So now that we realize that 1 out of 2 really is the same amount of pizza as 4 slices if it were cut up into 8 pieces, right? Now that we understand that they're really the same amount, and as long as they're the same amount, I can legally change the fraction. I don't need to leave it 1 out of 2. I can make it 4 out of 8. Okay? So we just got a common denominator. We couldn't add it as 1 over 2. The denominators were not the same. But since we know that 1 out of 2 is really the same as 4 out of 8, now the denominators are the same. All the pieces are the same size. I can literally count up the slices of pizza, and I have understanding there. 3 plus 4 is 7. And remember, we keep it 8 because it means each slice is 1/8. Okay? So that's the why behind the what that we do. I hope that makes sense. Feel free to pause the video and rewatch and replay the video as much as you need to kind of catch that, because there's a lot going on there. But I think you're probably, if your kids watch this, they're going to have that aha moment, and it's going to build some understanding there, okay? So looking at this week's work, one of the assignments at least, I had you just really working on how to add fractions that did not have the same denominator, much like the examples. Some of them, like if you look at number 6 and 8, this is one we didn't get a chance to cover so much, but I'll try to do my best to do at least one example there. So the ones that we did do, this is a good example right here. 3 out of 8 plus 1 out of 4, very similar to the one that we just did. But notice right here that, let me see if I can get the pencil icon going. There it goes. If you want to get common denominators, the easiest thing a lot of times is to pick the smaller denominator and ask yourself, 4 times what number would equal 8? Would equal that other denominator, right? Could I multiply 4 by something and get the other denominator? That doesn't always work, but on a lot of these, it will, right? So the question, you have to think about it, 4 times 1, no, that's 4. 4 times 2, 4 times 2 equals 8. And so since you figured that out, what you're going to say is, okay, I'm going to multiply this one by 2. And sometimes we put a dot for multiply. But remember, what I do to the denominator, the bottom number, I have to do to the numerator as well. That's a little rule that you're going to have to get used to. And then you multiply them, and it's pretty simple, right? 1 times 2, I'm going to come underneath, is really 2. And 4 times 2 is really 8. So we just figured out that 1 out of 4 is the same thing as 2 out of 8. 1 slice out of a 4-slice pizza is the same amount of pizza as 2 slices out of an 8-slice pizza, because the pieces are smaller if it's cut up into 8 slices, right? So we just keep the first fraction the way it is. The other one, we did it by a multiplier of 2. Got what's called an equivalent fraction, and now that the denominators are the same, we can keep the denominator as 8, but we add the numerators. 3 plus 2 is 5, so there's our answer, 5 out of 8, okay? So this is how you can get a common denominator without having to draw a picture. If it's still giving you trouble, you can always draw a picture. Pizzas or pies, circles that you cut up are really useful tools, and you can do that, right? Okay, so I kind of went over that on the marker board, and I just gave you a visual there. What I'd like to do is show you a situation next. We're going to look at number 6 right here if you can. We're going to look at a situation next where it's not quite as simple as the last couple. For example, notice that the denominators of 3 and 2 are totally different, right? You can't add them together as is. There's also another problem. The other problem is the smaller number 2, you can't multiply 2 times anything and get 3. I mean, you might be able to multiply it by a decimal, but we're not getting into that right now. There's no whole number that you can multiply. 2 times 1 is 2. 2 times 2 is 4. It's already too high. 2 times 3 is 6. There's no number that exists that you can multiply by 2 and get 3 on the nose like that. So what do I do when that happens, Chris? Well, you can actually do a little trick I'm going to teach you right now where you can multiply each denominator by the other one. For example, 2 can be multiplied by 3, and 3 can be multiplied by 2. Chris, what are you talking about? Well, what I'm saying is we're going to have to adjust both fractions. Both fractions denominators are going to have to change, because I can't multiply 3 times anything to get 2, and I can't multiply 2 times anything to get 3. So we're going to have to find what's called a least common multiple. Now what you might notice is both 2 and 3 can be multiplied by something and equal 6. You can multiply 3 times 2 to get 6, and you can multiply 2 times 3 to get 6. So what we want to do in this case is we want to find that least common multiple. In this case, it's 6. And we're going to multiply each denominator by something to get that 6. So for example, if I wanted this denominator to change to 6, I would have to ask myself, well, 2 times what would equal 6? The answer is 3. I'm going to say 2 times 3. 2 times 3 would equal 6, right? Well, don't forget, what I do to the denominator, I have to also do to the numerator. So we're going to go ahead and do that. We're going to multiply that out and change this fraction. 1 times 3 is really 3. Right? And 2 times 3 is really 6. So we just change 1 over 2 to 3 over 6. And that is an equivalent fraction. 1 out of a 2-slice pizza is the same as 3 out of a 6-slice pizza. Now, we have to do the same thing over here. What do we multiply by 3 to get 6? 3 times 3 is too high. That's 9. But if you said 2, you're right. 3 times 2 would give me 6. So I'm going to multiply 3 times 2. And what I do to the denominator, I have to also do to the numerator. Okay? So now that I have figured out the multipliers, now we just perform the multiplication. 2 times 2 is really 4 in the numerator. And then I'm going to do the same thing at the bottom. 2 times 3, that's really 6. So these are the new fractions. It turns out that on this particular problem, I couldn't use either one of those denominators. I couldn't use 2 over 3 and 1 over 2 because there's no way I can multiply them by something to get the other. So I actually had to multiply each each denominator by something so that they're common. And it just so happens I can multiply 2 times something to get to 6, and I can multiply 3 times something to get to 6, making 6 the new denominator, and that's sometimes what you have to do. So this is a little bit more of the challenge one. I put a few on there because I thought, why not go for it? Now that the denominators are the same, we add up the numerators. 4 plus 3 is 7, and we keep the denominator of 6. All right? Chris, that looks funny. The numerator is bigger than the denominator. That's okay. That can happen. It's called an improper fraction, and we'll build on that later. But anyway, feel free to pause this video, watch it several times. That's what I like about videos. you can hear me as much as you need to without wearing me out, so to speak, right? But hopefully that gives you a little understanding there. This is how we can add fractions, and it's a very important skill. It's not going anywhere. You're not allowed to just overlook this and, oh, well, I'll just move on. It doesn't work that way. You're going to have to do it over and over and over, especially when you get to algebra in the middle school grades or the high school level years. Okay, I love you guys. Let me know if you got any questions, and you can shoot me an email if you do, or leave me something in the comments, but I'll catch you on the next one. Peace.
Upside down and inside out, about to take your education on a brand new route. Because I'm Mr. Morris and I'm here to say that it's time to teach math in a brand new way. Because if you think that your math ain't great, you're starting to hate, feel you can't relate. Well, if you're no fool, be sure to stay tuned. There's a new way of learning flows into you, yeah.